Test. There we go. I reckon you can hear me now. Is that true? Can you hear me now? Marco Polo? One second, friends. Got another phone call here. Okay, what you didn't hear me? Oh my goodness! What just everything that seems to. It's like everything that could possibly happen at the same time that has happened at the same time. So what happened was, I hit the go live button, and normally when I hit the go live button, I turn the music on, let people queue in, and then I go to my iPad and I log into that so I can see the messages while I'm doing the stream. And then I get set up and whatever. I hit the live button and then my kid calls. So I'm like, oh, okay, well, I gotta deal with this. Where's I'm getting spammed. 1 second, friend here. Yeah, anyway, the second phone call, that's the third phone call I've gotten in the last 5 minutes. Very, very tediously. So no, my kid called and it's fine. No big deal, but you always got to pick up when your kid calls, right? So, I'm behind the 8 ball is all I'm trying to say. Happy Friday, everybody. Hi. Good to see you, Dan. Hi. So this week they released the brand new Spring Cloud Leyton release, and it's just chock full of goodies. But I haven't had a chance to really dive right into it. And I was thinking, well, I'll do that and I'll just put together a video and it's going to be great. But then I realized I can just do that on live stream and we could learn together. It'll be more fun that way. So let's do that, huh? Like we'll figure it out. It'll be kind of an adventure. Some of the stuff I'm aware of, some not yet. So we'll dive in together. So Spring Cloud Leyton is out the door now. Good question. What will be the impact to Spring Source because of the Broadcom VMware deal? I don't know. Seems okay for me so far. It's not great, obviously, but it's not bad. It's just another thing. I don't know. I'm here. It's too soon. Nobody can really tell you what's happening, but it looks, I don't know. We'll just have to wait and see, Okay, so let me see if I move this down there. Okay, can you see my screen there? Hi from Poland. Hello, everybody. By the way, to those who celebrate, happy Hanukkah. To those who don't, then happy Friday to you. Either way, nice day to be alive. So look at this. Spring Cloud Leyton is here. Okay, this is, by the way, the big feature, the thing that that you should understand first and foremost when you look at any Spring Cloud release is that normally it follows pretty quickly a Spring Boot release. And so, of course, Spring Boot 3.2 came out on Thanksgiving Day, which is the 3rd or 4th. Oh, Lucknow, India. Hello from India. The 3rd or 4th, 4th Thursday in November. So that was just a couple of weeks ago, right? And so we've got this new Spring Cloud release building on top of Spring Boot 3.2 GA. Okay, and there's just all this like cool stuff in Spring Boot, but there's also Spring Cloud. So I wanted to talk about Spring Cloud a little bit here today and just kind of explore some of the new stuff. And I guess we'll just kind of figure it out together, huh? Well, first of all, there's an extra bullet point. There's an invisible feature that is in Spring Cloud Kubernetes that, if you're lucky, you can discover what it is. It's like a bonus feature, I guess. With that hidden bullet point is there. All right, so I guess let's just start at the beginning, start that Spring.io. And I guess the first thing I want to try out is the new Spring Cloud Gateway. Okay, so Beautiful Cloud 3.20, okay, going to use the Spring Cloud Gateway. We're using the MVC gateway. So this is the big feature, big thing, which is actually a brand new project if you think about it. Is we've got what has historically been Spring Cloud Gateway. It's built on top of the reactive stack, right? The long-running Spring Cloud Gateway project, which is the successor to Zool, right? Zool is the original gateway. I wonder if we even support Zool anymore. Do we? No, thank goodness. Well, maybe we do. I don't know, but we don't have it on the initial answer because it's not a recommended path, right? That's for sure. So we have the reactive gateway. This has been there for years, and I've done, oh my God, I don't know, a dozen videos on it, including just a broad sweeping thing called Spring Cloud Gateway Redux years ago. And this is nice. We built this as a successor to Zool. Zool was the original gateway from Netflix, and it was okay, but it was built on top of a blocking synchronous API, and the API itself is terrible, right? Like it worked, and thank you Netflix for giving the world what amounted to be very useful software, but also it was just really painful to work with. Also, Netflix, understandably, reasonably, didn't open source everything. Why would they? A lot of the stuff that they had was specific to their very particular runtime infrastructure, and built on top of AWS. So if you didn't have that in your deployment, and why would you if you're not Netflix, you weren't going to benefit from it anyway. So a lot of the really useful batteries that you would hope would be included weren't. And so we actually ended up shipping a bunch of filters for Zool in the Spring Cloud Zool integration in the earliest versions of Spring Cloud. And it worked fine, but we ended up shipping a lot of the really useful stuff ourselves. We had to write those filters and ship them ourselves. The API was clumsy, and also the gateway itself was sort of limited in so far as it couldn't really do other things like WebSockets or whatever else. It didn't have back pressure and so on. So it wasn't great for the kinds of workloads we could envision people needing gateway to be great at, right? And it didn't support the HTTP2 as well. It's just a lot of issues, right? So we released Spring Cloud Gateway, which is and it had a custom DSL built on top of the component model there. Well, it was a brand new project. You couldn't drop in your Zool filters, but you didn't need to. Also, we provided a lot of the same things out of the box, and so that worked well. But contemporaneous with that, we also released a functional style for MVC programming. Okay, and so that style. Let's see. You bring in the web support, and that style. Java 21. By the way, this is the other thing that's so good. Is just no more Java 8 and 11 here. It's just Java 17 or 21, and really just 21 is the only one you should be using at this point, right? Okay, so Gradle, Maven. I'm going to use Maven for now. Gateway, Spring Web. Let's just start with this. Okay, hit generate. Open that. Downloads. UAO cloud.zip. Okay. UAO is just unzip and open, yeah. So cloud application. Good. So contemporaneous with that release of the original reactive Spring Cloud, we also released a component model for functional MVC, right? So, and you could do it in reactive first. It was a reactive component model first, and then we ported it to work with blocking synchronous I/O, right? And here's what that looked like, right? You'd have an HTTP. You could have a predicate right there. You'd have a get handler, and then you could say, okay, I want to match, let's say, hello, right? And then you provide a new handler function, right? So this is the style that was originally a reactive thing, but we made it so that it works for MVC. So this is actually using Tomcat underneath the hood right now. I'm using the servlet stack is my point. And this is a functional style handler for HTTP. So I say server response .ok.build. Whatever. Okay. I can pass in a body, and the body map equals map.of message. All right. Hello, Spring Pants. Okay. Or hi, Spring Pants. There you go. Okay, and that's the body. I'm going to pass that in, map. Hit go, hit that, and then I guess, what is this? What's the issue with that? Yeah, okay, there we go. That's my simple HTTP endpoint. This is not gateway yet. Let's just take it a little slow here. So, okay, start that application up. Localhost. And what do I want to do here? I want to close this. Safari. Localhost 8080. Hello. All right. There we go. Okay. So there's my simple HTTP endpoint, and that's the functional style. First, it was reactive. Then they made it work in the regular sort of MVC style. Okay. And it's nice. It's a really convenient style, and you can do this. You can create custom routes with custom predicates as well. So I can create my own matcher to describe how to match a server request. Like I can match, based on some database rule or something like that, right? Simon, that's a pretty good idea. One thought I had, Simon, our old friend, he says, one thought I had about the initializer, a toggle for the next version's EA and a VT flag for Java. What is VT? That's the one thing I don't understand. But everything else I love. Like I like the idea of it, like a button that says just sign me up for the latest and greatest. That'd be cool. Yeah, I don't know. VT though. What is that? Virtual threads. Yes. Haha. Well, yeah. Well, okay. So what would that do? I guess it would just put spring.threads.main. It would just do this, right? Spring threads. Is that the idea? It would just make that thing default. Yeah. I can see that. Okay. I hate to do this to you, Simon, but would you please file an issue? Greetings from Romania. That's nice. Hi, welcome. Thanks for joining us today. Appreciate it. And India and Poland. And I don't know where you're all coming from, but it's just great that you're here. It's just so good. It's so good. Feel very lucky. Okay. Yeah. Oh, the property to yeah. Okay. So yeah, you know the drill. It's a GitHub.com Spring IO initializer, which is the is that the implementation? So GitHub.com. People don't know this. Initializer. This one. Yeah. This is the quick start generator for Spring projects. It's the actual code that gets deployed for the API for start.spring.io. There's actually a web app that's separate from this, right? And that is over here. That is one of these things over here somewhere. Spring website, and no, that's not it. Initializer, maybe is that it? No, I don't think so. Well, whatever. So this is the initializer. Is this the project or the actual? Oh yeah, this is the actual project that is used. Okay. What I always get these confused. Start.spring. Here we go. Start.spring.io, start site. So if you go to here, Spring.io, start.spring.io, this is our implementation of the initializer. The initializer itself is the library that provides the API that supports, configuring and generating a zip file with your build in it, right? With your Java or Kotlin or Groovy and Gradle and Maven-based Spring applications, right? So that library, you can actually fork it, and you can add your own configuration to it. So we use this library here in our implementation of the library. This is actually a website that uses the auto configuration from the initializer module, and then we use that to configure our start.spring.io experience. So depending on what you're trying to do, if you wanted to configure a custom, you can have your own like start.yourorganization.io, have this little property file there, configure it, fork it, change it. And yeah, I'm not sure, Simon, where you would file your issue, but probably here, probably start.spring.io, and then maybe they move it to the initializer. I'm not sure, Okay, so we got this simple HTTP. Oh, good question. Spring Boot Kotlin also supports coroutines, correct? How virtual threads compare to coroutines? Look, I am a huge Kotlin fan, and it's fair, in my estimation, to say that Kotlin is a nicer, cleaner language than Java in almost every respect, because, of course, it's newer. And so they had a chance when they built it to not make a lot of the same mistakes that weren't mistakes when Java was made 30 years ago, almost 30 years ago. But, let's talk again in 20 years and we'll say the same thing about Kotlin. There'll be a new language that is nicer than Kotlin. And if only because it was created brand new and it was able to avoid some of the things that weighs Kotlin down in 20 years, but maybe today we don't think of as being weighing it down. And so I'm a big Kotlin fan. That said, friends, this is one of the few places where Java, inarguably, has done better than the competition. And it was not just Kotlin. It's done better than C#. It's done better than Rust. It's done better than Python and every language except for Go. And even there, I'm going to say that Go is almost as good. Not quite. It's still not as good, but it's so close that it shouldn't matter, right? So let's take a brief digression because the virtual threads here, this is also important to understand this new gateway feature, right? So I'm going to comment this out. I'm going to just take a brief moment to talk about virtual threads here, friends. And in order to, we'll look at the low-level feature, okay? Let's look at a demo here that I stole shamelessly from Oracle Java Developer Advocate, Jose Pomac, right? Jose, there we go. Okay, Monsieur Jose Pomac. And by the way, yeah, exactly. It's great point there, Simon. Java is slow and steady. It doesn't aggressively change things. It does a very good job of integrating things. I quite love Java's approach. It means that we're stuck sometimes with some compromises that maybe a brand new language wouldn't make, but I can appreciate why they did it, right? The generics thing is a great example of that, right? And also the sort of weird approach to threads up until recently is an example of that, right? These are concessions that Java has made in the interest of preserving the stability of the language. And so, we should all be very grateful. And I am endlessly grateful for Java. But it also, sometimes it feels nice to just use a language where everything just feels well designed from the get-go, right? And Java is now, I think, to a point where it's really good for most things. But here, what they did with threads and virtual threads is not just really good. It is better. And it's very rare. It's been a long time since we Java programmers have been allowed to feel arrogant about our language. But we have earned it in this one instance, okay? It's this one thing. So let's take a look at this. And this is an example, again, I stole from Jose Pomac, the one, the only, the amazing Jose Pomac. We're going to, and by the way, he was on the show, Jose. Oh, also another thing, not that you asked, but check this out. Speaking of Jose Pomac and so on, I found something. I did the DNA. Not that anybody asked, but this is kind of interesting. This is my little personal discovery this morning. Let's see. Okay, go away. Downloads. All right, check that out. I did my DNA, and it turns out I am. I have some Belgian in me, which I didn't know, Simon. That's cool. Like, not a lot, but I do. French and German and some Belgian, and that's neat. And then lots of Irish, English lineage. No surprise, I guess. But what surprised me, Simon, is I didn't know there was some trace bits of Belgium in there. That's cool. Okay. Anyway, so these virtual threads. Okay, let's take an example. Okay, we're going to do this the hard way. I'm going to create a new an array list of threads. Okay, and it's just for var I equals 0, I is less than, let's let's say 100 or even 1,000. Okay, not a lot of threads. It's not about how many so far. I'm just trying to create enough that there's contention. All right. Oh, gone. Audio's gone. Can you all hear me? Somebody said audio is gone. Can you hear me? Oh, thank God. Okay. Okay. So okay. Okay. Well, sorry. Okay. So I'm going to create 1,000 threads, and threads.add thread dot, and I'm going to use the platform threads, unstarted, new runnable. And what we're going to do is we're going to just create a bunch of threads, and then I'm going to go through each thread, and I'll say t.start, and then I'll join each one of those threads. Okay. And I'm going to print out each thread. I'm going to take some notes in the execution of each thread, and I'm going to print out what I've observed. Okay. So new concurrent skip lists set. Okay, there we go. Okay, so there's the observed threads, and I'm going to say observed.toString. All right, and I will sleep 100 milliseconds, and I'm going to then take note of the current thread if I'm in the first thread. Okay, so index, I'm going to store this so that it's effectively final, and then I can say if index equals 0, then I will take note of the current thread name. Okay, so thread.currentThread.toString. All right, and I'm just going to try on. There we go. So I've got this little bit. I'm sleeping for 100 milliseconds, and then I'm taking note of the current thread name, and I'm adding it to that concurrent set, which is going to dedupe. You know, even if it's on the same thread more than once, it'll just get added to the list of one, or to the set once. So I'm going to copy and paste that 2 times, 3 times, 4 times. Okay, so we're going to sleep 400 milliseconds total, and then take note of the current thread name. And now this is an example of a blocking operation. Blocking operations are the enemy of scale, right? And so the way the problem with this is that you're sitting there waiting for something to finish, and then you're on line 51. Then you go here, and you don't move. The code, the thread, the flow of execution is stuck on line 52, and it doesn't get moved for however long you're on that thread. Okay, and that's a problem, right? Because it means that nobody else can use this thread in the system, and threads have been historically a very expensive thing. So you definitely don't want to waste time on a thread when you're doing nothing. You're literally just sleeping and waiting. You could do that. You could free the thread up and give it back to the operating system and to the runtime to do something else with it, right? And so the idea here is every language wants to give you a way to avoid this. And you know what else is a blocking operation? Input stream.read. So or output stream.write, but more importantly, input stream.read. So imagine you use the REST template or the JDBC client or the REST client or whatever, and you're making a call to another network service. Behind the scenes, there's going to be a socket, and you're going to get an input stream, and then there's going to be some reading of that input stream. You're going to do input stream.read, but you're calling another website. You're calling another service. You don't know when that's going to come back. You don't know when the data is going to arrive. You don't know if it's going to take forever, if it's going to be instantaneous. You don't know if there's going to be a little bit of it or a lot. And while you're waiting for input stream.read, you're stuck. You're doing input stream.read, and the flow of execution is stuck on the same line, unable to move forward, which means it's unable to get to the end of the runnable, which means that it's stuck on that thread. So we call that a blocking operation, okay? And this is just to simulate that. I've got 4 blocking operations, and then I'm taking the name of the current thread, and I'm using platform thread. So this is what you would have gotten if you had just created a regular thread up until recently, right? If you use Java 20 and just created a regular thread, you would have gotten a platform thread. So this is exactly like the code we would have written in the last 20 years. Okay, so I'm going to run this. Let's go ahead and run it, and then start it. And then I'm going to print out the results. I'm going to run it. It's going to start a bunch of threads, which are going to sleep. Each of them is going to sleep. I'm going to then force all of them to finish. Basically, I'm going to join their time, and I'm going to wait for all of them, and then I'm going to print out the results of what I've seen during the run. Okay, let's restart. Okay. So no surprise, since we're using platform threads, we did the worst possible thing. We ended up waiting 400 milliseconds and blocking, right? We're only on one thread. That's not good, right? Okay, and this is exactly what you'd expect too, because look, I'm testing only the very first thread. I'm saying if it's the first of the 1,000 threads, then why would it change threads? I'm in one thread. It's the first one, right? Why would it change? Okay, well, but that also means I'm wasting time. I'm wasting time on that thread. I'm wasting time on all of them. But we can see that one thread was stuck waiting for this execution to happen. Okay, now what happens if I go to virtual threads? All right, go here, same program. All I did is I swapped out of virtual, and now I'm actually on different threads. Right, thread 1, thread 2, thread 3, thread 4, etc. So each time I did the thing, the runtime realized, hey, you're blocking. I'm going to move this thing off to the side. The runtime will monitor for that thing to finish, and when it's available, then we will automatically restart the flow of execution from the next line. So you will be on one thread here, but you'll be on a different thread here. You'll be on one thread here and then on a different thread down here, right? And so it's all transparent to us. You don't see me writing callbacks. There's no continuations that I have to worry about explicitly. There's nothing, right? And so this is really, really convenient. Obviously, other languages have something like this as well. And this is where I come to tell you theirs isn't as good, right? So what they have in other languages like Kotlin and JavaScript is async await, right? So async await. And so here, let's say I have a function. I have to say function in JavaScript, right? And by the way, async await came from C# and was then integrated into TypeScript and JavaScript and Python and Rust and whatever. So a lot of other languages have this async await. Let's say I want to get some customer data in JavaScript. Well, I can't just do this, right? So it used to be I would have a get customer by its ID, and then I have a callback. And this is like Node.js, 2009 era, right? This is tedious because you end up getting like, okay, well, the old style would be customer equals get customer one, and then a callback here with the record, and then you do, and you let's say I want to get the profile or something like that, right? Whatever, profile equals get profile for customer, passing in customer.id, and then another callback here for the profile. And, whatever. And so you get this nested nonsense. This is like 2009. So they realized, okay, well, we could do promises. So now this can return a promise. It's all blah, whatever. And I could do customer equals get customer. And I'm now not using a callback. I'm just returning this thing that's more easy to change. So I avoid the nesting. And then I can do this kind of thing like that, right? And this is kind of like what we have in the reactive world. It's a programming model based on pipelines. Okay, and it's nice, it works, but again, you definitely realize that you're dealing with asynchronous stuff. So then they added async await to the language, and here you still return a promise, but if you decorate it with async, and now you can use this new constant var. That's nice. Now I can do await get customer, right? So I'm still returning a promise, but the compiler sees, well, I said compiler, the runtime, whatever, sees that I'm doing async await. It sees that I have this custom keyword here. And it knows if I'm decorating the function with async and I use await when I call it, it'll automatically chain things for me. So now I can do, async await and write code that looks more or less, synchronous, right? Customer.id, etc. And so I can debug this. I can put my breakpoint there, and I can see what the value of customer is once it's evaluated, and I can do the same thing for profile. But behind the scenes, if you could do this, if there was some easy way to do it, the current thread, if I could do that, you would see that the thread of execution before this async and after is different, right? And so that's actually really, really powerful. So I'm changing the threads. But I have to, in order to get this benefit that Java is giving me, I can use async await, but the problem is I have to use it everywhere that I want this behavior, right? And it is nice. So C# had this first, right? C# had this feature like 15 years ago, a long time ago. And it's really good, but it also means that I have to add async and await to everything. And if I want to call an async function, well, guess what? The function that I'm in has to also be async. So you end up getting this, you end up having to paint all your functions with either async or not async. And so suddenly, if you're doing proper, scalable code, you're going to want as much of your code base to be async as possible. So you end up with async everywhere. It's like public now, right? I want public async functions. Well, that should be the default, right? It should just be, it just feels weird. And also, if you don't have async, then you can't call those other functions. So now half your code base becomes walled off behind this async context requirement, right? Okay, so that's not great, right? Not great at all. And it's better than the promises, but it still means you have to change a lot of your code. You have to add async await everywhere. And the same thing for C# and whatever, okay? All right, well now, the result they got is pretty good, but we have it even better. We get the same result, don't have to change our code. It just works. The only thing we have to change is the thread. That's it. And suddenly all the code that we wrote 20 years ago using threads, suddenly that works. You get this non-blocking, scalable virtual thread, right? And it automatically moves from one thread to another, moving that blocking operation off the thread and off to the side. So that's amazing. It's an amazing result, and they just added it seamlessly. Most of us don't create threads low level like this. Most of us do it with an executor service, right? Certainly you should be. Executors. So you can use the new virtual thread pool. It's not a thread pool, actually, it's an executor. And you can submit threads just as normal, right? New runnable. So you can submit threads, and behind the scenes, it doesn't actually pool it. This is not a thread pool. It doesn't bother. It's so cheap to create threads now. Like I can actually do 1 million threads now, no problem, right? The runtime doesn't care because it's all virtual. It's not going to take up 2 megs of RAM for each one of those. But even here, like if you plug in, Spring uses executors all over the place for your web front end, for Tomcat, for your data, for whatever, right? All sorts of threads, right? So the question then is, okay, well, do I have to override all those thread pools? You can. Spring Boot is pretty flexible in that respect. We have configuration interfaces and bean overrides. You can plug in a bean of type task executor pointing to one of these virtual thread pools, and that'll work. But again, do you know all the places where it's required? Do you even want to know? No, of course not. So you can upgrade to Spring Boot 3.2, set this property, and we'll do it for you. So now, friends, going back to Gateway here, now I can write code on the Servlet API, which is a blocking API. It's not reactive. I can use input stream and output stream read and write. I can set virtual threads, and now I'm getting the kind of scalability I would have gotten if I was using reactive. So now suddenly using a blocking API for my gateway instead of a reactive one doesn't feel like such a bad idea, right? So that's the core idea behind this new Spring Cloud Gateway, is I have a new functional gateway API. It's built on this exact MVC style functional composition API, right? And it's blocking, but who cares? Because we have virtual threads, so it can scale really well. So now, and they've actually, it's not the same API as the reactive one, right? They actually took a different direction here. They said, okay, we're going to build this new gateway on top of the older, well, when Gateway first was created, this didn't exist, but or it wasn't really it wasn't so easy to use, and it certainly didn't exist in the MVC world. But we're going to use this functional MVC style, right? So remember, Gateway came out in 2017, I think, and then Spring Boot 2.0 came out around then, and Spring Framework 5.0, and that's when we had the reactive types. We had the reactive functional DSL for HTTP endpoints, but we didn't have the MVC one. That would come later. So this is the MVC, not reactive DSL for HTTP endpoints. And now here we have Gateway based on MVC, not reactive, and it's using that DSL that came right after the first one came out. So is virtual threads? So okay, couple of great points here from the the gallery here. So one thing that Simon points out, which is a great point, avoid pinning, right? And so an example of pinning is I'm doing a blocking thing, like if I'm doing input stream.read, but then I do a synchronized block, right? Whatever, if I have a monitor, like monitor equals new object, right? If I do synchronization and then I do input stream.read, well, the runtime can't help me here. It can't move this off to a different thread. And so we defeat virtual threads. Now, if you do this, if you do input stream.read or thread.sleep and inside of a synchronized block, then you would just get the same behavior as you would have gotten in Java 20. So it's not like it doesn't break your system, it just defeats the scalability. It's the same. If you were happy with the scalability you had in Java 20, then all this does is it gives you that same bad behavior, but it's not like your code stops working, it's just not as scalable. But obviously there's ways around this. Don't do synchronized reads. That's it. Just move your read outside of the synchronized block and then do the changes to the state in the synchronized block after you've done the read. So yeah, that's a good point. Don't pin, okay? Otherwise you're going to lose the benefits of this, the non-blocking. Okay, and the other thing is, are virtual threads supported by JDBC or similar to RDP? Yes. Well, so it depends on your driver, right? But like, yes, a lot of them are, right? And you do need to check. Some of them have different things, and I would love to have a list of all the JDBC drivers that do support it. I know Postgres, I think, supports it, right? So I use Postgres, so I feel pretty good. But I don't know about all of them. I don't know about MySQL in particular because I never use it because it makes me itch. So okay. So we got that. Let's go check out this DSL now. Let's get back into Gateway with all that background, okay? We've got two things going for us that make this new Gateway project even more compelling. We've got virtual threads, and we've got this new, and I say new with air quotes because it's like 6 years old now. We've got this new MVC functional DSL, okay? Both of which make building a gateway in the way that we did just all the more useful. So let's take a look at well, here, let's do this. We just slot right in, right? So path is going to be hello. Is there any need to make changes to legacy gateway code written with reactive in mind? No. If you're happy, leave it as is. Absolutely. And reactive, again, gives you more benefits than virtual threads. It's just that the most important benefit, the thing that everybody thinks about, is the thread efficiency, the scalability. And if that's where virtual threads and reactive are the same. And if that's all you want, then you can start with virtual threads and be happy. But if you've got legacy gateway code, and I use air quotes there, it's not legacy, it's fine, use it if you like, then stay with it. You're fine. It's actually the more mature ecosystem at the moment too. So arguably, it's where I wouldn't jump until you're absolutely sure you want to jump or you need to jump. But a lot of people use Gateway as a standalone like appliance kind of thing, right? And so who cares if that particular code is reactive? All your use cases are going to be met there. If you want to add gateway functionality to yeah, if you're going to add gateway functionality to a new code base and you're starting with MVC, then this is for you, right? Okay, so another great question here. Will reactive code evolve to virtual threads code? I mean, there's no point. I'm not sure what I don't know. I mean, maybe Reactor behind the scenes will do something with virtual threads, but from our purposes, there's no difference, no changes required. So it doesn't matter, right? It's moot. If you've got reactive code, it's fine. Keep using it. And actually we just supported, we're always adding to that story. So we actually just added a reactive cache manager support, right? That theme, the goal has always been to get reactive to the point where you can do all the big things that you could do in Spring. You can do it in a reactive way now, right? And so that has happened. And by the way, the reactive thing is also really interesting because it does change architecture, right? Remember, constraints inform architecture. If you want to understand why somebody built a thing the way they did, look at their costs. Look at how much they spend on a particular thing, and look at what resources they've got. So for new projects, high throughput, do we really need WebFlux or WebMVC on Spring Boot 3.2 will suffice? Yeah, it should suffice. You should definitely benchmark it. Don't take my word for it, but that's the thought, right? That's the idea, is that virtual threads will give you the same kind of scalability without requiring you to abandon your blocking IO APIs. Okay, so one of the things that I always talk about, and it's just so evident here, is architecture. Constraints inform architecture. So, for example, we talk. If you've been writing software for a minute, you know about back office versus a front end sort of software, right? And we used to talk about back office processes, right? Like I might have. Goodness, think about all the received wisdom that we've all known about. So let's say I want to send an email. Somebody goes to my website, they fill out a form, and they upload an image, and they put in their email. So I've got two things I need to do. One is to take the image and then sample it down, make sure it's that fits in a certain size, so that way it's not a 5 megabyte image. Instead, it's smaller. And also I want to send an email. Well, both of these things take time, right? They take not ages or whatever, but maybe a couple seconds, right? Maybe even a second. Who knows? If the image is like 40 or 500 megs, maybe it's going to take a little longer. Who knows, right? And maybe I want to wait for the SMTP server to work, or I'm calling some sort of slow back office API. All that to say, this takes time. So the conventional received wisdom is don't do that in the web thread pool, right? Move that off of the web front end thread pool. It can't be there. And the reason we do that is because that web thread pool is precious. There's only a few threads. You want to make sure that you don't lose those threads, right? So now the question is, does it really matter? Like, do I need to move it to another? Like the way you would implement that before is you'd have another computer, another node, with like a Kafka or RabbitMQ listener or JMS, or something. You'd send the message over. It would asynchronously get the message, do some processing, and then send a response back, right? And that way you're not in the main front end thread pool. But now, like if the cost of doing something blocking is only a few kilobytes, then maybe I don't need to do a separate back office thread thing. Maybe I can just do it in the web front end now. Just a lot of it. A lot of things just become more interesting. A lot of things that would have otherwise been very easy, natural candidates for microservices. Now, maybe it's a monolith now. Who cares? Okay. So anyway, back to this gateway. Okay. So the pattern. So basically, I'm not changing anything here. Like this is. Let's go look at the docs here, friends. Spring Cloud Gateway docs. Okay. PR. Spring Cloud Gateway. Here we go. Release notes. More information. Gateway. This is there you go. That's the route. That's the old DSL. Where's the new? Learn. Reference docs. Reactive. That's so we have to distinguish between the old one. So this is the reactive old gateway reactive server. Here's the Spring Cloud Gateway Server MVC. Okay, Java Routes API. So there you go. Same exact DSL, right? There you go. Let's just use that example. Okay, and Git. I guess they don't need this yet. You can just start with that. Actually, that's still fine. This is what I had before, actually. And now you have a DSL. It's the same DSL, so we're plugging in a custom route. The handler is actually these DSLs, right? These handler functions are static methods on the handler functions class. So handler functions. And you can see there's common methods that look very similar to the reactive ones. So you've got forward, you've got HTTP, you've got HTTPS, you've got lookup, you've got all sorts of stuff in here, right? But this is not the only stuff you've got. You've also got there's a bunch of this is where it's kind of interesting is your options are no longer control spaceable, right? You have to know which classes to look for. But like for example, if I want to do a token relay, right? Is it token relay functions? There you go. Then I do that, right? That's a filter, right? So actually, that's a good point. If I want to, this is the predicate. I'm matching /hello, and I'm sending it to this, okay? But let's say that when I send it, I also want to have a filter. Well, I can do a filter after or before, right? Maybe I want to do before, and then I can plug in this right here. So let me see. Token relay function. Required type is function X. Filter. What's the issue with that? Maybe it's just filter. Yeah. Oh yeah, okay, that works. So I'm going to plug in this filter to configure the token relay. And I thought there was, so does the, that's a buy. Okay, server response. I mean, filter will work, right? There's also, let me see. So filter functions dot dedupe, fallback headers, preserve host, redirect to. These are all the things that you can do in the same way that you would have done in the reactive Spring Cloud Gateway. So I can change the path. I can do rewrite, path rewrite, right? So maybe I create a endpoint. This is a bit of a tortured example. I'm going to create an HTTP endpoint on the current Java process. I'll create a gateway rule that routes to it, and that does some rewriting. Okay, which is so stand back. Okay, we're going to have a gateway proxy that proxies an endpoint on the same node, which is useless, but you can do that. And then we're going to use regular expressions. So get your hard hats on. We're going to do some seriously bad things. GitHub.com. Okay. .com. Let's see. Where am I? Repositories. Okay. Studio. I had an example somewhere of because I don't mind writing code on stream, but regular expressions are, that's too much. I like you too much to do that to you all. So let's see. Where did I put that repo that had the example? That was fine. V3. There we go. Gateway. Source mean. Java. Here we go. Here's an example. Okay, so we're going to use this rewrite. I don't have OAuth set up, but if I did, I would use that. But I'm going to use this. Okay. Okay, so what I'm going to do is when something goes to API/blah, I'm going to rewrite the path to go to just blah. Okay. And so this is a little stupid, but I'm going to call back the current node because I don't want to build another microservice. So I'm going to say when somebody goes to / it's API/hello. Actually, is that right? Yeah, that's going to be like that. Okay. So when somebody goes to API/**, which is like a wildcard, which is just anything, right? Then forward the request to our current node. But then the question is, what if that? I don't want an infinite loop. So I'm going to rewrite the path to strip out the word API and just replace it with that. And now I'm going to create another HTTP endpoint here. Let me just use a controller for example. I could actually insert it there, but hello. Okay, response body. Get mapping. Hello. Map Spring. Turn map of hello. Okay, pretty straightforward. Okay, hopefully I don't infinite loop myself here. So again, I'm going to make a call to localhost API hello, and my expectation is I'll get this data here. because it's going to remove API and then forward it to the other endpoint. Localhost 8080 API. Hello. Please. Yeah, there we go. So I called /API hello. It hit this filter function. It hit this path, the predicate here. And it said, okay, I'm going to forward it to this. But before I do that, I'm going to filter it. And the filter I'm going to use is a rewrite path. So it changed the path so that it would then go to just /hello, which would then match this controller. Okay. Now, obviously, this is a bit of a, this should be some other host. That's normally how a gateway works. You don't rewrite rules to your own computer, but you could, is my point. Okay, so we're on the same page on that. Is there any questions on gateway? Like, it's a new API. It doesn't look the same as the old one, but it does look similar to the MVC, the functional MVC model. So depending on where you're coming from, this is going to be a bit of a disappointment or a really good deal. If you don't know about gateway, but you do know about the functional MVC model, then good luck. You now know about gateway, right? You're already in the game. Good stuff. And I think it's a big deal. A very nice thing. I got another great question. Oh, what do I think about Webflux? I love Webflux. I mean, yeah, it's reactive. I'm a big fan. How about virtual threads with observability and following traces and spans? Anything to take into account? No, should just be fine. Like virtual threads right now. So this is they released Java 21. Java 21 has virtual thread support, but there's actually 3 things. When we talk about Project Loom has 3 features, right? One is virtual threads, which we already have. That's GA. It's out there right now. Then we have structured values and structured programming. And then we have scoped values. That's what it is. That's the 3rd part, right? And so this is right now you can use a thread local, right? You can use thread locals in virtual threads. The problem is, well, thread locals create objects that are assigned to each thread. In Project Loom, I can easily create millions of threads, right? There's no reason I couldn't do that, right? Oh, actually, by the way, I did. See, as an example, I had that in there from earlier. I didn't comment it out, right? And so when I ran this example here for the gateway, I ended up creating 1 million threads. That's how good it is, right? And my program still started in 0.7 seconds. So like Loom is really, really good. But the thing is now, if I have a thread local, and it's going to have a value, I now have 1 million values, right, in my program somewhere, right? And so that's not good. That can be very expensive. And so you can do that. It works. It's just you have to be careful you don't create too much memory, is my point. And so they're going to have a way to fix that. That's going to be called the scoped values, and that's coming soon. Yeah. Can I elaborate on a little bit on transactional in Webflux? No, transactional is so Webflux. Again, there's 2 things. There's the reactive transaction manager. Reactive transaction manager is the equivalent of the platform transaction manager. They are not the same API because obviously, but the reactive at transactional works on any method that has at transaction. It works on methods that that return a publisher, a Flux or a Mono, right? And so it then follows the pipeline. It follows the publisher. So if you have a pipeline with multiple transitions, it makes sure that the value, it stashes the current transaction with the pipeline. It's not bound to a thread. It's bound to the publisher. And so the way it works is very different. It has nothing to do with virtual threads. Okay, to your question there. But it does work. You can use that transactional for years now on threads, on reactive pipelines. Okay, so yeah. So when it comes to observability, it works. Virtual threads and observability and actuator and micrometer, all that stuff works just fine. Okay, so that's gateway, friends. We did it. We have a certain gateway example. Took us a while. We're now like an hour into this, and we've only covered 1 project. Let's keep going. This one, CRUD mappings for functions deployed as REST endpoints via Spring Cloud Function Web. Friends, this is really cool. I saw Oleg Zirakuski talking about this at Spring 1 a few months ago. So let's say support for put. Okay. Yeah, look at this. So it's just somebody sent a pull request. Look at that. That's so cool. we never thought about Spring Cloud Function being used like that, but I'll accept it as a feature request. Support for put and delete method. I want to implement a CRUD-based REST API using Spring Cloud Function on AWS Lambda. I'm unable to find an example or documentation that demonstrates how to implement common HTTP methods. So again, Spring Cloud Function, for those of you who don't know, is we had this project years ago called Spring Cloud Stream. We still have it, obviously. But Spring Cloud Stream was a programming model that allowed us to hide through the concept of binders the details of a publishing of a pub sub messaging system like or RabbitMQ or Redis or Google Cloud Pub Sub or whatever, right? And so we have this like programming model. You can say this method gets invoked whenever a message comes in on this logical destination. What is that destination? Well, that destination is maybe it's a topic in Kafka, maybe it's a queue and an exchange in RabbitMQ, whatever. You don't care. You just have this logical name called whatever. Let's say customer, requests, or maybe that back office example of emails. Maybe I have a queue or a logical destination called emails, right? So that programming model was really, really good. I liked it a lot, and I still like it. But they then realized that when you're doing serverless, really you're just dealing with functions. You're just dealing with callbacks based on events being published via the gateway from your serverless platform like AWS Lambda or Scale to Zero platforms. Okay, and so they extracted out that functional component model and pulled it apart and separated it from the binders that allow you to talk to pub/sub messaging systems like Kafka. So now the function component model is, you can use that with Kafka, but you can also use the same functions with AWS Lambda or whatever, open functions or open FN or whatever it's called. You can use it with that. So now we have this Spring Cloud Function component model, and the basic idea with Spring Cloud Function is you literally just write the function, a Java function, right? Like this, string integer, right? And you export that function, and Spring Cloud Function can then connect it to either Lambda or Kafka, right? Look at that, that just boils down to nothing. So that function, I write a little bit of configuration. I tell Spring I've got a functional bean, and then through Spring Cloud Function and through Spring Cloud Stream or through Spring Cloud Function, I can now connect that with either a serverless request or a Kafka or whatever. Okay, so I've got two different destinations for the same exact function definition here, right? Which is great. It gives you reuse of code. Now, what this is doing is it's saying, okay, I would like to write controllers and have those controller, the same kind of controller I just wrote here, like this. I would like to map that to Lambda, right? And it started this year, right? It's not even that long ago. It's just April of this year. And so yeah, Oleg, I love this guy. Look at this. Look at this. He actually did it. That guy's so good. So let's actually take a look and see how it works. Okay, we'll go to here, Spring Cloud Function. We've got samples here. Okay. Oh, actually, no, I think it's back up. So here's, AWS routing, Azure, cloud events. That's a CNCF standard. GCP, they have events there. Regular POJOs. Lots of different functions supported. And by the way, this also works great with GraalVM. So you can create a Spring Cloud Function app using the Spring Boot 3 AOT, the GraalVM native image support, and you can start up. So you get something that runs in like no time at all and runs really quickly. I don't know, but I suspect that this also supports CRAC, the coordinated restore checkpoint support that just came out in Spring Boot 3.2, which came out, like I said, in the end of November. So I wonder if, like, for example, Amazon, they have AWS Snap Start. I wonder if that works with Spring Cloud Function. I don't know. I haven't tried it. But the native stuff does work. So you can use GraalVM and build a Spring Cloud Function app with just a few beans like this, turn it into a GraalVM native image that starts up in a few milliseconds, Because remember, you're in a regular function app, you don't have Tomcat. You don't have the whole web runtime. It's a lot faster, right? This is pretty fast on the JRE, but this same code, if you were to run it in GraalVM, would be a lot faster. One thing I did notice, friends, this gateway, the old gateway code for sure supports GraalVM. I know that because I helped build that code. So if you use reactive gateway in GraalVM, I did some of that work, and then obviously a lot of others built on it, and so it works really well now. I did try this. I did try the gateway stuff, and as far as I know, it doesn't work in GraalVM, and it doesn't seem like it's too big a deal. I was gonna see if I can write a poll. Maybe I'll do a live stream, and we can stream and fix it together on live stream. But let's press on. Okay. So anyway, we got Spring Cloud function. This is the component model. So now he's saying, what if I could do a web endpoint? Okay. So Spring Cloud starter function. What is this? Adapters. Yeah, you've got gRPC, you've got cloud events, you've got GCP, you've got Azure, AWS, Azure Web. Is that what this is? I just want an example. Let's see. Okay, that's the binder for. This is the kind of code I don't want to ever write. That's why I love Spring, is that somebody else is doing all this horrible stuff for me, because now I can just write nice, clean, simple, easy to understand code. But okay, this is not the samples anymore, is it? We have to go back to the samples. Samples, AWS, Azure, Web. What does this give me? Here's a controller. Nice. Okay. So I have a controller. Is that the right one? Doesn't feel like it. That feels like a regular controller. README. Let's see the README. Oh, that is the right one. Look at that. So you've got this wow. So you write the code like this, like this controller. You just write a regular controller. This is exactly the kind of code you'd write in Spring MVC or Spring WebFlux or whatever. You use get mapping and post mapping and whatever. And then what is this? This is your configuration for Azure Web Functions, okay, Azure Functions. And I guess you don't have any configuration proper here. So then, yeah, okay, so you just run the program. And then if you want to invoke it, you run locally or you can deploy it. But when you make requests to the Azure Web Adapter endpoint, it'll then invoke. Oh, wow, look at that. You can actually, so you're calling, basically you would deploy this to Azure, you would invoke a function in Azure, and then Azure will call a controller method via the Spring Cloud function binding here. So I can add, like here's an example of me adding countries by calling this function endpoint in Spring Cloud function. So that's pretty cool. That's the new thing. That's what they're talking about, is this new support for using controllers as functions. Nice, very, very cool. Yeah, as AWS or Lambda. So Spring Cloud stuff, oh, that's really cool. Okay, and that's another win, where now I can take even more of my business logic and my knowledge and my understanding of the component model and take it to new places. You know, this is what we try to do, is to give you maximum leverage for your uses. Okay, OpenFame, so the Java HTTP client support. This, I think, is the new. So you will notice that we've done this all throughout the stack. In Spring Boot 3.2, is we have a HTTP client configurer. Okay, so this doesn't make any sense anymore because I didn't bother with the Spring Cloud function. But let's say I am creating a REST template. Okay, well, if I create a new REST template, the convention is to use the REST template builder. Okay, and then build it. Right, and you should. That's been true for years. Right? REST template builder is a Spring Boot-ism. Yeah, it's in Spring Boot. I'm kind of surprised this is not pushed into Spring Framework, but it's a Spring Boot thing, and you can configure your REST template, right? So I can provide a function, right? So here, new JDK. Okay, so this is a JDK client HTTP request factory. If you don't do this, then the default will be the original client HTTP request factory, which is, I think, what is it? It's just the regular one, right? The one that was based on sun dot whatever, right? Simple client. This is the original. Yeah, that uses standard JDK facility. So this is the old one from Spring Framework 3.0 from 2009. Okay, and it works, but it's not. What is it using? What is this URL? Is it just using? Yeah, it's just using regular Java net. So it opens a connection, a URL connection, by making a network call with the Java URL, right? But this API, it's in JDK. It's been there forever, since like Java 1.0, but it doesn't support options, right? It doesn't support a lot of the new stuff that you would expect a HTTP client to support. So the recommended setting is to not use the default. This is the default still for backwards compatibility, but instead to use client HTTP request factory. Sorry, this one, JDK client HTTP request factory, which implements client HTTP request factory. This was actually another contribution from the community, this time from our buddy Martin Danum, who's a very prolific member of the Java and Spring community. It was merged, and it made its debut in Spring Boot 3.2 and Spring Framework 6.1, which just came out a few weeks ago, right? So this is based on the new Java HTTP client that came years ago. It's a lot newer than Java Net, right? So this came out Java 11. So this is like in the last 10 years, right? And so you can specify that for your REST template or for your new REST client. That's another nice feature here, right? And here, I like the REST client style better, the configuration. I say builder.requestFactory new blah build. I don't have to use a lambda there. I'm kind of surprised I can't do that here. The asymmetry feels weird. Like it'd be nice. Yeah, whatever. Yeah, so that one just takes a connection. And it, arguably, I could stash this as a variable here, right? Put that in bean and then reference it and share it here. I don't know why you'd have both of these things in your program. I don't know why you'd have a REST template and a REST client, but you can share this. I'm pretty sure it's thread safe, right? Yeah, it's got an executor, an HTTP client, a read timeout. That's why you might want to have instance-specific ones, is because that you might want to have a different read timeout. But basically, this is read only, so it's thread safe. Yeah. So it's just going to create a new request each time. Okay, so anyway, that's the point. That's the REST client and the REST template and the new JDK client support. So I guess that's what this is, okay? The Spring Cloud Open Feign support. Support Java 11 HTTP client in Spring Cloud Open Feign. So if you're using Feign, which is a declarative interface-based way of creating an HTTP client, then we will also support the Java HTTP client as well, right? That's this new one, just like we do in the REST template. Now the thing is, friends, I don't think you should use Open Feign anymore. Okay, this is us, just us nerds talking here. There's now another big thing in Spring Cloud Leyton, the one we're looking at right now, is we have load balance support for the new REST client, right? So let's take a look at that. So this is more interesting to me. We have declarative interface-based clients, right? And you've probably seen me talk about this before. This has been in Spring Framework 6.0, so Spring Boot 3, which came out a year ago and a few weeks ago, like 54 weeks ago. Spring Framework 6.0 and Spring Boot 3.0 have interface-based clients. So let's take an example, okay? So where's that host bin or HTTP host bin? HTTP bin? What is it? This one. Okay. So I just want some simple HTTP methods. Simple HTTP cats ninja. No, HTTP cat facts API. This one. Catfact.ninja. Okay. So Facts, sure. Get a random fact. Okay, so that's this URL here. Just fact. Yes, okay, so it's got a fact and a length. So now I want to create a cat fact client, okay? And I'll return a cat fact string, and it's a fact and length. Or length, long, just in case somebody has a real long fact or something, I don't know. Okay, and cat fact, okay? So now this is the declarative client support. You can do this in open Feign, but I think it's just nicer to do it using the new framework support. I'm not using something, this is an interface, of course. I'm not using Spring Cloud here. This is just Spring Framework itself. And there's Git Exchange. I can make a call to /fact. And I'm going to configure this client here, okay? So we'll create that bean. I'm going to use this REST client that I just created above, right? I've got it. I still have it here. I don't need the REST template. I'll just comment that out. It's not very interesting to me. And I'll say return, .builder.build, and then pass in .adapter. Doesn't the builder take one? Whoa, IntelliJ, what is that? Oh yeah, the adapter. So client adapter is different. So it's a REST client adapter. .create, passing in the REST client. Okay, .build, and then .create client. And I did this all in one thing, but you could probably tease them out, right? You could put this variable as a separate bean and then just inject it, right? That way we don't have to redefine that each time. This one right here. Okay, good. Inject that. All right. Hey, look, there we go. So now, and then that would inject the REST client. So now if I have other interfaces, they can all just inject the same proxy factory and get all the same defaults, say, using the same REST client and so on, but you can just change the interface. So now it's very easy. Okay, so I've got a client. Let's create a bean. Okay. This here. Do I already have a runner? This is the interesting thing is, do I have a runner already? Oh, I do. Of course, I've got this Loom demo. Loom runner. Isn't that amazing? Every time I start this program up, I'm creating a million threads and I'm waiting for all of them to do 400 milliseconds of work, and it's still. I wanted the RAM. That's where you would see that is now in the RAM, right? But it's not in that. Like compared to a regular Java program without a million threads, it's going to be a little bit more, right? Okay, so this is going to be cat fact client runner. Okay, whatever. Runner. And I'm going to inject this thing here. When the application starts up, I'll call .fact. I'll just print out the results. All right, good. Okay, so I'm going to run that. Here we are. Okay, so that's working, right? That's basic client. Now this is good for a third-party website. Oh, actually, how is that working? Does that work? No, it doesn't work. We don't know if it works because there's no fact. And the reason there's no fact, friends, is because I didn't tell it where to go. So let's actually put in the whole URL here. Okay, restart. And did it not run? I reckon. Oh, there. I had to wait for all. Oh, there you go. So that had to start. Okay, there's the fact. Okay, let's comment out this thread thing because it's that should be instantaneous, right? There we go. So there's the fact. The way you treat kittens in the early stages of its life will render its personality traits later in life. Oh, cats are great. So, pretty simple stuff. This is here. One thing that this is very familiar. If you've ever used Spring Cloud Feign or Spring Cloud Square retrofit, or even Spring, the experimental, but never released. You can still probably find it archived or something, but it's the RetroSocket project that I started for RSocket-based clients, right? You can use declarative interfaces and work with RSocket, work with reactive, work with HTTP and MVC. And it's consistent. It's the same programming model. It's the same HTTP service proxy factory style, and it's in Spring Framework itself. So to my mind, there's no more need for Spring Cloud Feign and retrofit and RetroSocket. Okay. And I can hear you say, well, wait, what if I want to do load balanced requests? Well, that's what they fixed in the new version of Spring Cloud. They have support for that. So let's try that out. And friends, in order to try this out, we need to set up some load balancing. In order to do that, we need some a service registry. Okay, so we're gonna have to set up Eureka or something like that. Okay, we'll go back to start.spring.io, and we're gonna use Eureka server and the web support. I'm gonna call this Eureka. This is a service registry for server-side registration and discovery. The idea is that it's like a phone book. Programs start up, they register themselves in the service registry, and then other services can call that service registry and ask it for up-to-date information about which services are running and where. It's like DNS, but more powerful because you're not tied to DNS, first of all. DNS is slow to update, and it's very, it's not very dynamic, whereas this can be very dynamic, okay? So we're gonna stand up at Eureka. Mind you, you can also use HashiCorp console. You can use Apache Zookeeper. You can use Kubernetes itself has a service registry. Cloud Foundry has one, so you can use all these things. Okay. So Eureka Java 21, good. Open that up. I haven't set up one of these in a minute, so this will be fun. Okay. Suggested plugin, Jakarta EE REST services are available. Why would you suggest that? So one of the nice things that IntelliJ has, have you all seen the new AI assistant, right? It's built into JetBrains IntelliJ products now. So if you go in PyCharm or Rust Rover or JetBrains IntelliJ or WebStorm, whatever, all of them have this. It's like the AI support in Copilot and Visual Studio Code. And it's really good. It's really good. And by the way, speaking of AI, have you all seen the new Google Gemini demo? That was really cool. That was that came out yesterday or the day before. Blows my mind. I mean, I don't know. We have to see, obviously, but it looks like it could give ChatGPT 4 a run for its money. Really, it looks amazing. So anyway, AI is well and truly here. It has arrived. It's now in my IDE of choice, so that's good. And you can ask it random questions like, what service registry implementations does Spring Cloud support? Carpal tunnel's causing me issues. Here we go. Yeah, Netflix Eureka. Thank you. Good. Console. Yeah, good. Okay. I mentioned console. I feel like I'm on top of it. Apache Zookeeper. All right. We also have other service registries like etcd, Gossip, Apache Kudro. Really? We have those in Spring Cloud? News to me. I mean, really? Did you hallucinate that? How do I use Spring Cloud to configure Apache Kudro? What is Apache Kudro? I don't know what that is. What? Did I look? It says Apache Kudro. And then I asked it, like, what is Apache Kudro? How do I use Spring Cloud to configure Apache Kudro? And it says, I'm sorry, but there seems to be a misunderstanding. Apache Kudro does not exist. There might be some confusion with Apache Kafka or Apache Kudu, but neither of these are service registries and hence cannot be directly configured with Spring Cloud for service discovery. Okay, I just finished telling the world about how cool you were, JetBrains AI. This was not your moment to shine, I guess. Okay. Anyway, I'm gonna just keep this. This is funny as heck. How do I save this? Rename this. That's hilarious. Okay, keep that. And what does dump chat do? Is that? Oh, okay, that's what I wanted. Save this. Hilarious. JetBrains AI hallucination. Okay. Oh wow, it even lets you open it up in the IDE. That's cool. Okay, no, enough of this nonsense. I'm done with you, AI. Thank you. You have helped me not at all. Okay, so we're gonna set up a service registry. This is easy, or at least it always has been. I haven't done it in a while though. So enable Eureka server. I'm not even sure if that's still required, but it used to be. And then you specify Eureka query. No, Eureka register with Eureka is false. Spring application name equals Eureka, right? And I guess that's it. Oh, it's going to start up on the wrong port. I got to specify the port. Let's ask AI again. I'll give it one more shot. On what port? It's like 7411 or 4711 or something. On what port does Netflix Eureka typically run on localhost? Okay. 8761. I got that wrong. Maybe I should drink another coffee. Okay, so 8761. So server port 8761. Here we go. Good job, by the way. Good AI. Good job. That's way better than that last one. Okay, so it's up 8761 localhost. All right, so we've got our service registry. This is the ye old Eureka service registry. It's been here forever. And I have no instances registered with it, but let's do that. Let's fix that now. And so we now need another app to register itself, okay? So go back to start.spring.io. No, start.spring.io. Thank you. Why am I doing that? Let's just use Safari. It's so much nicer. There we go. The service, okay, and it's gonna be web. It's gonna use Eureka Discovery Client, not the server. And I guess that's it. We're gonna use that, okay? Well, generate Maven 3.2 Java 21. Hit generate UAO. Okay, so we're gonna create a third one here. This is gonna be called our service, and we're gonna register this in the service registry. So let's see here. Application server port. So Spring application name is called service or whatever. Hello service. Let's call it that. Port will be 0. Well, it'll be a port or 0, right? Actually, do I want that? Yeah, it's probably fine. Server or port. Is that going to do what I think it does? Wait, yeah, actually, no. Just do this, Josh. You're overcomplicating it. There. So server port. And my service application, it's going to have a simple HTTP controller here at get mapping. Hello. Spring. Hello. Return map.of. Hello. Okay, and it'll be hello world. And just message. All right. Oh, message. There we go. Okay, so let's try that. Yeah. If we spin this up It'll spin up on a random port, I assume. Yep, discovery client. It should now have registered itself with the Eureka service registry, which I happen to have here. So remember, I'm going to refresh the page right now. Look at this. There's nothing here. I'm going to refresh, and now we can see hello service on a random port, okay? On port 62619. So in theory, 62619, I go to localhost 62619, hello. There you go. It made I got the hello world from this the service via the service registry. So now I want to be able to consume that that endpoint. You know, like let's imagine I have two of these. Let's run this again. You have to change your configuration here, right? To tell it not to. I want to be able to run more than one of these, right? So I don't care about AWS connection. What is that? Let's see. Can I do that? Can I allow multiple instances? You got to specify, right? So apply, hit OK, and then run again. Now I've got 2, right? And then I'm going to run again. Now I've got 3. Look at that. The UI has gotten smarter. I can actually see the number here. All right. So we go to Eureka, and it hasn't updated yet. Well, that's a bit of a bummer. Oh, because it's the same host. That's the other thing. Okay, so Eureka. Oh, it's the oh boy, service ID. I think service URL. You have to disambiguate the service instance, and it's the Eureka. Let's see here. What do we call this property? Because I usually use the like Azure Spring Apps. They have a service. They have a Eureka service registry, so I don't really do this on the local machine very often anymore. Instance. That sounds right. Instance dot app name. No. Maybe. Host name. Oh. Okay. Instance ID. That sounds like it. So I can do random, I think. Or is it random int. There you go. So let's try this now. Reload this. Let's see if that creates a different instance. That one of them is down. Okay, so that worked. I've successfully. So let's stop everything. Okay, so now they're all shut down. At least I assume they are. They're all, there you go. That one's down. That one is down. That one's down. All right. So there's nothing there. Now, restart. Okay. Restart this one. Okay. Oh, hey, thank you. Appreciate it. There, very, very kind of you. Thanks for hanging out. Okay, there's this one as well. So we got all 3 of these up and running. Okay, good. So we got 3 instances. Ignore this. This is just because I'm doing it locally in a production server. You wouldn't have that. Okay, so now I've got 3 different instances. Eureka sees all 3. I want to load balance. Okay, now we get back to the new feature. Okay, this little digression has service because now I want to be able to call that service. But you can remember in my client, in my cloud module thing that I was building, I used catfacts. Well, now I'm going to create another declarative client called hello, client, whatever. Okay, and here, get exchange is, and I could do this. I could do like local host, and then find one of the hosts and ports. Right? Where's the? Is it this one? Yeah, it's this one. Surely. Okay. There, port. This one. I could do this, and I could just talk to the same instance over and over and over. But that really doesn't get me what I want, does it? So map string. Let's just say record greetings. Okay. String message. Greeting. Okay, very good. So there's that. So I'm going to now create another client out of that one, being hello client. Okay, I'm going to inject the HTTP service proxy factory just like before. This one, create client. It'll be hello client.class. Okay, and I'm going to use that. Create another bean here, application runner. Hello client runner. Return args. I can inject the hello client dot greet. And we'll just print out the results there. And voila. Let's run this, restart the application just to see if that works. Okay. So there you go. Hello world, right? That has worked. But we're pinned to one instance, right? And so with OpenFane and and indeed, by the way, with Spring Cloud Gateway, if I was doing this in OpenFane, I could do like this. I could say HTTP, what did we call it? Service or hello service, I think. Hello service, right? And let me see if that's here. Yeah, it's called hello service, right? So I could use this logical name, and Spring Cloud Gateway would automatically, I would change this to be load balanced, right? And Spring Cloud Gateway and OpenFane would automatically substitute pick one of the three instances and put that in there for you. Okay, so now it's possible to do that with the REST client itself, right? So now I don't need to use OpenFane because my REST client is load balanced. Let's figure that out though. Okay, so here is the REST client that we've been using. Okay, let's create another REST client. Load balanced REST client. I assume you just configure it with the load balanced annotation, but I'm not sure. We're going to try it out. REST client dot builder dot request factory. This dot request factory dot build. I assume that works, or maybe I have to configure load balanced on the REST client builder. We can always just look at the documentation. That's fine. No shame in that. Okay, where's my... Okay, so what does this do? Oh, it's the builder. Okay, yeah. That's what I figured. So is this the test? No, this is the actual thing. So if you have a load balanced builder, yeah, okay. So we have to configure the builder itself. So bean load balanced builder. Sorry, REST client builder. Okay, load balance REST client builder, and you say REST client builder, whatever. And you can also specify this stuff. Okay, so I can put that there, and now I can inject this particular one. Okay, so I don't put the annotation there. I put it there. REST client builder. Okay. Or even better, actually, I can probably just disambiguate like that, right? I can do that. That's bean injection as well. So that should now be load balanced. So let's see if that works. So what does that give me? Well, first of all, I think I'm going to break the cat example. Because this is the load balanced. Wait. Do I need this? Comment that out for now, just to keep things simple. Okay. And for the cat client, don't need that. All right. So for those of you joining, we're looking at the new load balanced support in Spring Cloud for the REST client. And I've got an interface, and I'm going to call into Eureka, which is running in the background there, and just see if I understand how that works. So let's clean this up a little bit. We've got a lot of stuff here, and frankly, it's a lot. Okay, so we've got the client. We've used the service proxy factory. the service proxy factory in turn is using the REST client, and the REST client in turn is this thing up here, which is load balance. That's the assumption, right? So let's move everything down here so I can kind of keep it all in the same place. Okay, and then this, of course, I can just move back up to here since I don't have the REST template anymore. All right. Oh. There, okay. So let's see if that works. I'm not sure if this works. I mean, this is the service. Let's just, I guess it'll, only one way to find out. I think let's just start the program up and see what happens. No, it doesn't know the URL. Okay, so it's going to be, this is the gateway syntax. I think it's just this then. Okay. Okay. Time to look at some tests. Okay. Is there like a test I should be looking at? Is that load balance rest? Okay. Load balancer. I guess we can just look in the Spring Cloud Common support here. Load balanced REST client. Oh. Tests. I don't even know if it's, so how do we load balanced client, load balanced REST client builder. Did I miss what, this one? Where's my, I was just looking at the class that did this. This guy right here. Okay. So, so what is the syntax here, friends? Yeah, let's just look at the docs, probably in there somewhere. So search, by the way, have you seen all these wonderful docs? Look at that. Discovery client route definition locator. I want load balanced REST client reactive. Search in all of Spring docs. Oops. Okay, learn overview. Go to the nope. Hey, that's me. Let's see here. I just want the docs. It's so good. We've got like amazing docs. Quick start. Learn projects. Spring Cloud. Learn reference doc. Oh, that's a bummer. We gotta fix that link. Reference doc. Okay. Spring Cloud train. Load balancing. Okay. There we go. Load balanced REST client. Okay. There we go. That looks promising. If you want a REST client that is not load bound, okay, here we go. So you build a REST client like this. Okay, I got that right. See, this is the nice thing. And you can make this the primary one so that this is the only one that, so that cat example, if I wanted to keep that cat REST client and have the new REST client that's load balanced, I could do this. I can make this the primary one. It's not load balanced. And then for the use case where I have the need for the load balanced one, I can inject it by name or inject it by calling the method or whatever. Okay. Oh, and I can use it as a qualifier. That's pretty cool. Okay, so now HTTP stores retrieve. That looks right. So what's the deal? It's HTTP. Is it hello service? It's still hello service, right? Yeah. Goodbye. And then here. Wait, where's my StreamYard over there? Good. Run this over here. Close other tabs. Okay. Keeping it as simple as possible. To use it, add the Spring Cloud Load Balancer starter. Aha. That's probably important. So I probably want to do that as well. So start that Spring.io load. See, I'll bet you it's probably something as simple as that. Okay, add this. Wait, I'm using Maven. What was I doing? Okay, Spring Cloud Load Balancer. I wonder if that's the ticket. Okay, because it's like acting like it doesn't understand the URL, which tells me there's some dependency not being plugged in correctly. You know. Reload. Is this loaded yet? It says it is, but it doesn't act like it is. All right, here we go. Yeah, there we go. It's now in the class path. Great. Restart the program. Okay. Still failed. No instances available for hello service. That's great. Okay, so it's definitely aware that I want to talk to a service registry. And by the way, that's the other thing. I don't have the service friend. In order for this to work, this has to be a Eureka client, which it is. Good. But I need my thing to be a Eureka client as well, my cloud client. It also has to be on the same service registry. So I'll go here. By the way, did you see this? I'm not sure when this got here. Like you can edit starters. So I clicked on that right here, edit starters, click on that. And now I can say I want to do Eureka discovery client. All right, good. Hit OK. Okay, it's redundant. Let me get rid of that for a second. Get rid of that. And then edit starters, Eureka, hit OK. Oh, did I confuse the algorithm? Okay, hit OK. Okay, it did actually take. Okay, so that's fine. So now I'll go back, Eureka again. Oh, look at that. It actually knows what I've already got. And it's showing me what I already added. So, oh, that's really cool. Good job, IntelliJ. That's a big feature too. Oh, not as amazing as this hallucinating goofball over here in the corner of my IDE, but still pretty interesting. Okay, so I've got Spring Cloud Starter Eureka on the class path. That's the other part you have to have, right? Obviously, I can't believe I forgot that. Spring application name. Let's call this client. Why not? All right, there we go. Woo! Okay, so it's calling one of the instances of the service. Let's go ahead and I should have logged in the service itself. I should have logged on which host it's running or which instance. So let's do that, okay? What I'm going to do is I'm going to listen for an event, right? Static class controller. Greetings controller, put that here, put that there, put this all up. A separate class. Okay. Good. All right, so there's this, and now I'm going to listen for an event, which is the what is it? Port initialize. Void set port what is it? Server initialized, web server initialized event, right? Get that. Final atomic integer port equals new atomic integer 0. This dot port dot set server initialized dot get web server dot get port. Wow. Okay. So on whatever. Okay, there we go. So when that, so now I'm going to print out hello world from port this dot port dot get. Yeah. Good. So now, how do I restart all three of these? Does the services thing work for that as you'd expect? No, it does not. Okay, we can restart all three manually. Run 2 and 3. Okay. All right, good. So now they're all disconnecting from Eureka and then reconnecting. Well, this one have any of them successfully restarted? One of them is restarted. Here's the other one. And here's the other one. Okay, so now we have 3 instances. So now if I make this call again from my actual client, the cloud module, with the load balanced discovery, the load balanced interface here. Okay, so now restart this. It'll disconnect and reconnect to Eureka. Look at that. So it's port 63155. Okay, run it again. No, 63135. So let's just let's increase our odds here. Okay. Luck is not in our favor right now. So 4 var I is less than whatever 100 plus. Yeah. There you go. So you can see it's load balancing the requests across those 3 instances as it discovered from Eureka. So all that to say that you have you can use the REST client with OpenFeign, and that's great if you've got OpenFeign based code. But if you don't, then don't bother adding it. Just use the regular REST client support and the declarative interface client that's in Spring Framework 6, and then just use this, right? And use the load balanced REST client support that's now in Spring Cloud Leyton as well. So there's 2 bits. There's OpenFeign, which already supported load balancing, now supports the REST client, but also you can use the REST client with declarative interfaces, and it now supports load balancing. So I think I prefer that. I think I prefer that new way. It's a Spring Boot 3.0 and later way, but it's much more consistent, and it's built into Spring Framework. So you're just using the same primitives as you're expecting. The one drawback to that, by the way, is that in Spring Cloud OpenFeign, you just have an interface. You don't have to define the bean like I did here. You saw me, I had to create the proxy, HTTP service proxy factory and all that stuff. But it's not, actually, I kind of like having the proxy factory. And we are working on maybe having a way to do interface-based clients. Well, I don't know what'll become of that, but I submitted a PR, and there's other people have had the idea as well, and we'll see. It doesn't matter for now, but either way, I quite like this. So that's another big feature in Spring Cloud Leyton. Thank you, Spring Cloud. Okay, what else do we have here? Ooh. Spring Cloud Leyton. Okay, so Spring Cloud Gateway. We looked at that. We looked at Spring Cloud Function. We talked about OpenFeign, and I skimmed right over it, and we moved straight on to this one, which is the load balance support for the new REST client. Refresh scope on restart, a feature tailored to allowing adapting to environment changes. Oh, neato. Oh, okay. What does that do? So we have, again, Spring Boot 3.2 has crack support, right? Project Crack. And so Project Crack is, well, I talked about it in my latest Spring Tips video, of course, but Project Crack is a coordinated restore at checkpoint. It's a thing, it's an initiative from Azul Systems, and it gives you support for participating in CRIU, C-R-I-U, which is a Linux-only technology for taking a snapshot, in effect, of your running Linux process, and then saving that off to disk, and then using it to bootstrap, to jump right into the same process on another machine. And because you've got a snapshot of the data structures of the program when it was running, the snapshot allows this other process to resume almost instantly. You don't have to initialize all those data structures, right? So it's really, really powerful. And we have support for that now across Spring Boot. Not everywhere yet. I'm sure there's some little nooks and crannies, but like the big stuff, like if you're using a database and stuff, Spring Boot will automatically configure that to do the right thing. And basically, there's a life cycle, and you can implement the org.crack. You can add that to the library, to the class path, and that'll work. And I think we even version manage that for you now, right? So if you're using, let's see here, org, let's see, crack, org.crack. Yeah, it looks like it resolved it without me having to, yeah, 1.40. So I didn't have to do, we even version manage this dependency. If you add that to the class path, you can now participate in coordinated restore at checkpoints. I'm not going to show a demo. Do I want to show a demo? It's like, it's a real pain on the Mac to get it working. Because remember, it's a Linux-only technology. So you have to like, you have to use a Docker image. Okay, I'll show it. Let's do it. Let's go through it, okay? But it's, hope you're ready. This is like 5 minutes of pain. Refresh scope. So okay, before we dive into the actual crack demo, let's see what this new feature offers. Specify client registration ID. What am I looking at? I think they got, hey, that's the wrong link. Let me take that. Let me see. Okay, so what does this do? Refresh scope on restart. So what I imagine is happening is in Spring Cloud, we have the refresh scope. And the refresh scope is a feature that allows you to tell Spring to, when an event is triggered, a refresh event is triggered, it tells Spring to recreate whatever beans are annotated with at restart, or at refresh scope, right? And so I imagine that if you're, and that's a Spring Cloud feature too, the refresh scope. So I imagine that if you are you're in a crack-based environment and you've got a bean that's implementing I didn't then yeah. Let me think about that. So I guess what it means is it'll call that when the restore happens. It'll call all the beans. It'll recreate those beans too. So that's conceptually. So to understand what that means is, let's say you create an application using crack. Okay, there's a life cycle. Like I said, there's a life cycle called either resource. You have to implement that, or you have to implement simple life cycle, right? Or smart life cycle from Spring. So class my life cycle bean. Okay, so that component static class implements smart life cycle. So if you implement this interface, Spring framework will automatically call the start method when the program starts up. It'll call the stop method when the program stops, and it'll only consider this running if this returns true, right? So this is great for like services. Like imagine you wanted to have an email server or something like that. You could implement Smart Lifecycle, and Spring Boot will automatically start it up and tear it down in the context of the Spring application itself. So final application atomic. Let's see, running new atomic boolean. Yeah, and then I can say return this dot running dot compare and set. I'm expecting it to be false, and so I'm going to set it to be true. And then the opposite is true here, so I'm expecting it to be on, so I'll set it to be false, and then this will be whatever that is, right? So I now have like a little bean. I have some state here around whether the thing is running or not. And that's been true forever. Smart Lifecycle has been here since like Spring Framework 3, right? But now so you get a callback in Crack, you get a callback that says, I'm about to take a photo of the state of the JVM. So please clear out whatever sensitive passwords you've got and whatever ephemeral nonsense data structures we don't need. Like the last thing you want is for this CRIU technology to take a photo of your running process with plain text credentials being written to disk and with like pointers to sockets pointing to databases, right? That socket is a network. It's a construct of your network card on your machine. It makes no sense to serialize that. So this is a great chance right before, when stop gets called, right before the snapshot, right? Spring will call this right before the snapshot. It's your job to null out whatever password you've got and to close any socket connections, that kind of stuff. So that way the running structures that are there are the ones you want. And then when it starts up again, when it gets restored and it's reset on another node, this method gets called. And you get a chance to now reinitialize that database connection and all that stuff, right? Well, now, if this bean is at refresh scope, right? If you have another bean, like let's say static class at component foo, right? If it's reset, if it's a refresh scope, then this will automatically get called, I guess is the idea. It'll be recreated right after the refresh event, and it'll be recreated when there's a new restore. If you restore the snapshot on some other node, and it gets started up like that, okay? Long roundabout thing. So now that you understand the Spring Cloud feature, let's pull back and look at the Spring Boot feature, just the crack support, okay? And this is it's not so bad. It's just tedious. So I actually covered this in Spring Tips recently as well. Okay. Okay, here we go. So, is this the one? Docker file. This is the part. Okay, so what did I do? So, I have a cheat sheet. I'm gonna, because there's like steps. I had to borrow the example from Azul Systems Garrett Gunwald. 3 crack. Okay, client durability. Okay, so here we go. We have this Docker file. I guess this looks like the right one, right? Is that right? Which one did I use? That's the real question. It looks like this one, maybe. This is 3 weeks ago. I made changes to it. Okay. So, restart. What is the difference? What's the two different things here. Application properties. Oh no, that's just dev tools. No. Oh, okay, yeah. So the crack one is this one. This is the right one. Okay, so let's. Okay, so I'm going to take this dependency, Spring Boot Starter Web. I'm going to add. Okay, let's just do this from first principles here. Spring.io. Okay. Going to create this. Going to use. Is it on the web? No, it's not. We'll just do web. Okay. And hit that. Terminal. CD. Oh, did I do Gradle? I went to Maven. RMRF crack. Okay. UAO crack.zip. Here we go. Okay, friends. So what we got to do is create a Docker file. We're going to go here. We're going to create a stateful thing. I'm just going to copy and paste that code from this right here. Okay. Put that in there. Class. Okay. Starting. Okay. Stopping. All right. Close that out. Okay. Okay. So this. Let's see if that works just in regular Spring land. First of all. Oh, I put that in the wrong project. Over here. Where's my new one? Good. Okay. Restart that. Okay. Port 00. 8080 is already in use. That's fair. What is using it? Probably this cloud module that I had. Yeah. Okay. All right. Okay, so it started. So you can see the application was started when the web server was started, then the beam was started, and then the program itself can be said to be running. Now I'm going to stop it. Okay, so you can see stopping, right? And it gets this test gets run again as well. We get to ask, is it running? Okay, so now if it's running, then we get stopped, right? That's the important part. If you return false, then it doesn't bother calling stop or start. Okay, so that's regular life cycle. Start when the JVM starts, stop when it stops, right? I want to participate in crack and coordinate a restore checkpoint. And again, remember the reason we do this is because you can go really, really fast when you start up again, okay? And I implemented this Spring lifecycle, but I can also implement the crack lifecycle, right? And that's using the resource type. So resource. Did I not add the dependency here? Crack. Okay. Command Shift I. So this is you can implement these methods as well. I quite like implementing just the Spring one because that way I don't have to tie my code to crack. And also I don't have to worry. It's just, it just does the right thing for startup and stop and for checkpoint and restore. But so basically Spring behind the scenes implements this interface and then it calls stop in before checkpoint and it calls start in after restore for you. Okay. So you don't have to worry about that. Okay, so I've got this type. All right, good. And I want to turn this into a image here, into a Docker image. Okay. Okay, so we need to create a Docker file. Let's see. How do we create that Docker file here? That's the question. Got this Docker file. I guess I can just copy and paste that one from the website. Hopefully, I checked in all the relevant code and it works. Docker file raw. Copy and paste all that. Do I have my Docker file here? Yeah, I do. Paste all that in. So what is that going to do? That's going to download a JDK. And by the way, this is in a Linux dist. I'm running in a Docker image, which is a Linux container, right? So I'm running a virtual Linux container. That in turn is going to download this distribution. You have to use a crack-aware distribution of Java. I'm using Java 17 from Azul. Azul has a distribution called Zulu, and I'm just going to download that one to the Java home directory, openjdk.tar.gz. I'm going to extract it out into this directory, get rid of all the components. I'm going to make this folder called opt crack files. I'm going to run the program called crack. I'm going to copy the program from my local Mac into the Linux image, the Linux virtual, the Docker image. And then I'm going to expose port 8080, okay? Seems pretty easy, right? Yeah. Okay, so let's go here to the command line. And we'll do maven w get tests, of course, because I have no tests. Clean package. All right. And then we do the Docker build. So Docker build t crack latest, I guess. Let that run on my local machine there. So it's going to run all those steps that we just saw. It's downloading Zool right now. Okay. Okay. So now I've got this. If I look at that, I've got like, what's the Docker image? It's just called crack latest on my local machine, right? I didn't publish it or anything like that. And then I want to run the JVM application, ready to capture a checkpoint. Yes. So Docker run IT privileged RRM P 8080. Okay, so I'm running the Docker container called crack. I'm going to give it a logical name of crack, but I'm also going to run the container called crack. So the instance of the container called crack will also be named crack. Okay. Ooh, unknown file. Oh wait, I just want to run this. There. Okay. So now run the JVM application ready to capture a checkpoint. So I'm in the Docker image now, right, of this program, and I'm going to do Java -XX. I'm going to send a JCMD, right, a signal using JCMD to the Java program. Okay, so XX crack checkpoint 2 equals / opt crack files -jar. So it's going to, if I do a checkpoint of this program, it's going to send it out to that directory. Then I'm going to run the program, which is in the container that we're in now, right? App practice jar. Thank you. Yeah, so remember, I'm running the Java program that we just built. I'm now in a Linux container. And so I'm going to note the process identifier. It's 9, okay? We're going to run another shell. Now I'm back on the Mac. Docker exec -it -u root crack bin bash. Okay, so I am running a shell in the same image that we just had. Whoops, no such Docker ps. Oh, it's this one. Okay, well. Okay, so now I've got a shell, a root shell in that same Docker image. I'm gonna now, I've got the, and remember, I'm still in the first shell. I'm still in the same Docker image. I'm in the same Linux distribution in two different shells. In one console, I have this Java program running, and it's got process identifier 9. I'm gonna then use JCMD to capture that checkpoint. I'm gonna take a snapshot of the working memory of that program. Okay, so JCMD 9, right? That's what we saw earlier. JDK.checkpoint. Okay. Okay, so it just called checkpoint. I sent a signal to the program, and you can see the program over here now has stopped, right? And if we look at opt track files, we can see the contents of the program that were just written out to disk, right? And now I want to run the program again, but this time I'm not going to run the jar. I'm going to tell Java, the Azul distribution of Java, in this Linux container, I'm going to tell it to run the Java program by looking at the checkpoint instead. So remember how long it took to start this thing up the first time on the JRE inside of a Linux container inside of my Mac, right? So I started this virtual Linux container Java virtual machine. It took me 0.92 seconds, which is slow, right? Because remember, when I run the program on my local machine, on my Mac, it's like, less than half a second, much less than half a second, right? So now I'm in the Linux container. I'm going to run it one more time, but I'm not going to run the jar. I'm going to run the from the snapshot, okay? XX track restore from equals opt track files. All right. Oops. Is it just 1x? Look at that, huh? Amazing. So, like, it went. You didn't even see it, did you? It was so fast. So, boom. The first time I did that, 60 milliseconds to go from 0 to warm and running. And by the way, you can see it reevaluated this bean. I logged out the start. So Spring didn't get recreated. All the constructors and all that stuff, none of that got called again, right? The only thing that got called are those callbacks that we implemented, the simple smart lifecycle interfaces, right? Or the resource interface. That's it. But otherwise, it's the exact same state as we had when we took the snapshot and we wrote it to disk, right? And so now, I guess what this new feature is doing is saying, okay, if you're using refresh scope and you're using crack, and by the way, this is really good, by the way. This is what I was asking about earlier. I wonder if there's support in Spring Cloud Function for crack, right? I would be very surprised if there isn't, but I don't know. Okay, anyway, very, very cool. So super fast, and that's now supporting the refresh scope, which is great. Good job. Okay, Spring Cloud Config Server. Oh, native support, Gravium native support. For that, okay, so let's try that out. And by the way, we've already seen this other feature, which is the Antora documentation, which is really good, right? I'm able to search here across all the Spring projects. I can say, show me everything about the REST template across all the Spring projects, Spring Cloud Commons, Spring Cloud, search all the Spring docs. For some reason, that's not working. I don't know why, but otherwise we saw it earlier though, and it'll get better. We'll figure this out. Okay, so anyway, let's check. This is the last thing, and then I guess we're gonna call it good for my friends. Oh, interesting. The Spring Cloud Kubernetes, by the way, they just updated the dependencies, so I'm not gonna really show you that, but you should know that the Kubernetes Java client, github.com, Kubernetes Java, something like that. What is it? Kubernetes Java client. Kubernetes client Java. Okay. So we upgraded to the latest version of this code because we're awesome. And if you elect to, you can bring in the AOT support, and you can create native images, and that's because of this guy, right? I helped contribute that. So now you can create a Kubernetes controller or operator or whatever that uses GraalVM and native images and starts up in no time at all, basically. And that's because there's now official Spring Boot AOT support in there from last year, right? I did that last year. So if you go to start.spring.io and then choose Kubernetes, it's a bummer. There's no Kubernetes dependency there, but we do manage it. My point is there's a project called Spring Cloud Kubernetes. We manage the dependency for you. So if you bring in Spring Cloud Kubernetes Starter, you get the AOT, you get the Java client, and then you can easily add the AOT support as well. Okay, so let's look at this last feature, which is really cool, which is I can use the config server as a native app. I can build that. So that's not, config server, config. All right, Java 21, Maven, config server, GraalVM, web. All right, here we go. CD downloads. All right, config server. Okay, so the way this works is we have the config server, which acts as a facade, a proxy by which you can access centralized configuration on GitHub. So github.com or any Git repository, really. I wonder if I think it even works on local. Yeah, let's just try that. We'll just do localhost here. Yeah, so desktop mkdir config cdconfig git init emacs application dot properties. Okay, message equals hello Spring Cloud. Okay, so git add application dot properties, git commit, Okay, so I've got a local file system Git repository here on my local desktop config directory. I'm going to tell Spring Cloud to talk to that. So Spring Cloud config Git. Let's see. URI? Yeah, there we go. Home desktop config. Okay. And I think we should do a port. Let's just say 9090. It's arbitrary. I think, what is it? What do we normally do? 8181, something like that? I forget what the convention was. Okay, here we go. It's up and running. Okay, here we go. Sorry, just realized I'm not logged into the chat here. Hello, everybody. Okay, so am I not live? I think I'm live. Yeah, okay, good. Yeah, okay. So we've got the config server up and running. How do we test it? Well, we can build a client, okay? I'm gonna go back here, config client. You can also hit the REST endpoint, but let's just do this, it's easier. Client. All right, web config client GraalVM, hit generate. All right, and we open that up. CD downloads, UAO config client. There we go. Okay. Config client application. Here we go. So now what I'm going to do is I'm going to connect to that. I'm going to specify the config server. Config. Spring Cloud config URI. Oh, it's 8888. So if I had done that by default, so that's what the convention is. Okay, let's do that. Let's go back to the config server. We'll restart this on 8888. Okay. Good. So now I don't need to specify that anymore. It's the default. It'll work. And here, a environment. Okay. Message. Okay. So I'm going to get it two different ways. I'm going to get the key from the environment directly like this. All right. And I'm also just going to inject it like that as a property. So value message string message. All right. All right. Spring Cloud. Oh, I've got to specify. Oh, I do have to specify it. So Spring. This is the new style. Well, not new. It's last few years. Config server, and you can just specify it. If it's the default host and port, you can just leave it like that. I think. Let's see. Did that not work? Oh, I guess you do have to specify something. Let me see. Here we go. Spring Cloud. So config server. Where did it? I mean, just localhost 8888, right? Sure. Is it about timing? Like if I set up a, wait, does this only fail because I'm trying to do the call that early? No, it fails regardless. Okay, good. So is the server running? That's the other question, I guess. Cloud module, that's this one. Don't need it. Config client, okay, care, but no, we don't want that one. We got the service. That's the load balance service from earlier. Don't care about that one right now. This is port 8888. It looks like it's running. So what is the issue? Do load. Okay, it is that. You have to do this and that, looks like. And the resource is not optional. Oh, right. Spring application name equals config client. Does that matter? Nope, doesn't seem to make the difference here. Oh, is this how our journey ends? What did I do wrong? I'm doing something so obviously wrong, but I forget what. Oh, does my config server, is it running? That's the other question. Does it actually have a config server? So do I have to do @enable config server? Maybe that's what it was. Yeah, that's probably what it was. How much you want to bet? Well, actually, I'm not sure if that's what it is. Bean factory. Okay, let's go back here. It's doing something different. Oh, port is whatever, 0. Hey, there we go. It worked. Okay, so I had to enable the config server. So, okay, friends. So we know the config server is now working because I'm able to create a config client to get the configuration from it. Fine. The big feature, the big new thing, is that now, if I go to my config server here, I'm going to stop it. And remember, back on the initializer, I went and chose GraalVM. So I have this extra native image plugin here. So I can now do skip test p native compile. All right, there we go. Let that run, and this will take a little while. It'll fail too. Why did it fail? Code generation does not support refresh scope. Am I using refresh scope? Well, that's a bummer. What did I do wrong there? I don't think I'm using refresh scope. Are you? Well, I'm going to call that a bit of a miss. I think I'm doing something wrong. Let me see if that issue on the blog is native image support for config server. Okay, so what does this point to? Okay. What is the situation here? Well, clearly there's something happening that I don't quite understand. Like I gather there's some unintended, mixing here. Spring Cloud config server. What does that bring in? Oh well. Okay, I think, my friends, we did it. We went through everything. I'll figure this out offline. I have no idea what the issue is. I'm sure it's nothing. But otherwise, that was a really good run. We did a lot of stuff today. We looked at just all of the new Spring Cloud release. Actually, Spring Cloud Leyton is now GA. Go get the bits. Don't try generating a native image for your config server yet. Maybe it works. Maybe I'm just doing it wrong. Maybe you should try it. Maybe it works just fine. I don't know. But thanks for hanging out. I hope you got something out of it. We'll do more of these, of course. I love doing these live streams. I've got a bunch of videos also sort of in the works. So maybe I'll release one tomorrow. I don't know. We'll see what happens. But it's been good. Have a great weekend, everybody. Hope you're having a great day, a great old day. I'm glad you're here. I'm glad we got to hang out. Thanks for all the cool questions. Hope you enjoyed Spring Cloud Leyton as much as I do. This is a really good release. A lot of really cool features, quality of life features. In addition to building on Spring Boot 3.2, which is, brings with it a whole bunch of new opportunities like Project Crack and the new REST client, the JPC client, and improved Graalvm AOT support, and so much. It was fun. All right, my friends. Bye bye. Have a good one. Bye bye. Thanks, everybody. Appreciate you.